Okay. This section is about derivatives of products and quotients. And this is the formula. The formula makes no sense unless you just sit and really think about it. But if you see an example work, this looks way more complicated than what you're actually going to do. And a lot of you have already done the homework for 12-2 just by looking at what the video that I did, and the ones that worked on it were doing it correctly, so I'm pretty sure y'all are going to be fine. So this first one we've got here is a product. It is the product of factor number 1, which is that one, times factor number 2, which is that one. Now you could multiply those out and use the power rule that you already know how to use to get the right answer. You would get the same answer. But the product rule, especially if it's not something as simple as a binomial times a monomial, the product rule actually is a lot more efficient and you'll get done a lot quicker. So the first thing that we're going to want to do is you need to take the derivative of each factor. So the derivative of 2x plus 3 is 2. And the derivative of 3x squared is 6x. Now this is the way that the product rule says that you do this. In order to find f prime of x, it's going to be adding two things together. The first thing we're going to add together is the first factor.
Miss Flynn, I'm really sorry. How did you get that 2 and that 6x?
That's the derivative of 2x plus 3.
Did you just use a calculator for that, or did you just...
No, I just used the derivative rule out of 12.1. 2x to the first power, 1 comes down in front, 1 times 2 is 2, times x to the 1 minus 1, which is x to the 0.
Which is 1, right?
Right, so then what you have is 1 times 2 times 1, which is 2. And then the derivative of 3
and then
is
3 is
0.
0. Okay, I was like,
Okay,
wait,
that what
2 plus
got
3
you?
is 5. Yeah, no, I'm sorry.
Okay,
Long week so far, but it's Tuesday.
okay. 2x plus 3 is our first factor. Our second factor was 3x squared. This is where the product rule tells you how to do the problem. These are going to swap derivatives. The derivative of 2x plus 3 is going to go partner up with the other factor. And the derivative of 3x squared is going to go partner up with the first factor. So they're just going to trade derivatives. And at that point, your calculus is done. You finished with the calculus at this point. This is the critical first step. You've got to be able to employ the rule. That's what the rule says to do. It says take factor 1 and multiply it times the derivative of factor 2. And then add factor 2 times the derivative of factor 1. So everything that I do after this is just algebra. It's no longer calculus. So 2 times 6 is 12x, and x times x is x squared. 3 times 6x is 18x, plus 2 times 3x squared is 6x squared. And that equals, since 12x squared combines with 6x squared, that's equal to 18x squared plus 18x. Okay? Now I'm going to do this one time to show you that you can check your result. If you really are worried about it, it's easier to check on a calculator by just putting in what you got for the derivative and then ask it what the derivative of the function is, and go compare your tables. But if you want to check it using your power power rule, what you do is you realize that equivalently f of x is 2 times 3 is 6x squared. And 2 times 3 is 6x times x squared is x cubed, not x squared. Plus 3 times 3x squared, 3 times 3 is 9x squared. And if you take the derivative of that, you get 3 times 6x to the 3 minus 1 plus 2 times 9x to the 2 minus 1, which comes out to be exactly what we got down here, 18x squared plus 18x. Now, as far as which method is easier, it's a wash. It doesn't make any difference which one you use. The point is, it's just like arithmetic. As long as the method you use is right, as long as you do the procedure right, your answer is going to be the same, whether you do a different step process that still is a legitimate process. But the product rule is going to turn out to be a lot easier in most cases. So here's our second example. Everybody in here just wants to jump up and down and say, yes, I want to multiply that out, right? With a radical in it.
Absolutely not.
Absolutely not. I do not. I do not wish to multiply that out at all. In fact, the first thing I wish to do is call that x to the 1/2. I don't even want to deal with that square root sign because I don't have anything to do with it. I don't have a rule for it. But if I turn it into a 1/2 power, I do. So then I have x to the 1/2 power plus 3. That's my first factor. And x squared minus 5x, and that's my second factor. And the derivative of x to the 1/2 plus 3 is 1/2 times x to the negative 1/2 power. And my derivative of x squared minus 5x is 2x minus 5. So here's your factors.
Wouldn't it just be 2x though? Because the derivative of a constant is 0, right?
The derivative of this constant is 0, yes, but this is not a constant.
No, but you do the 1 times 5 and then 1 minus 0. I mean 1 minus 1 is 0.
Right.
So 1/2.
Are you talking about this?
Yeah.
Okay. So here's the 5x, and when I take its derivative, this is 5x to the first. And if it's 5x to the first, the 1 comes down in front, right? Times 5x to the 1 minus 1. And then that gives us 1 times 5 times 1 minus 1 is x to the 0, and that's 1. And 1 times 5 times 1 is 5. Okay? It's because you have the x. The derivative here was 0 because that was a 3. Is that making sense now?
I got you.
Okay.
If the x goes to 0, then you
Yeah.
leave the x.
If the x goes to 0, then you just don't write it down.
If
because it
it's
just
negative, then you still have to write it down.
Yeah, if it's a negative power, you have to write the negative power down, but if it's a 0 power, you're good to go. Okay? So what I have here is I've got y, that's these two factors, and these are the derivatives of those factors. And what my product rule says to do is to get y prime, I'm going to take the first factor, which is x squared plus, x to the 1/2 plus 3. And multiply it by the derivative of its partner. And then I'm going to take the second factor and I'm going to multiply it by the derivative of its partner. And at that point, your calculus is done. I know it's not pretty, but if you will type that into My Math Lab just exactly like it is, and be sure and enter parentheses where you need them and enter your fractions correctly, as long as you enter it incorrectly, that is the correct answer, and My Math Lab will take it. Now, actually multiplying this out is a pain. Apparently, programmers in My Math Lab just love to multiply stuff like that. They can have all the fun they want to. I just assume not.
So you can put that in there as an answer?
Yep, sure can.
You'll
I
accept,
think it's like multiplying all out,
Going
like,
through and doing it all.
You don't have to multiply it all out.
you'll accept that on a test.
Yes. This is the grade. This is the part I'm going to grade.
So all you
You
gotta do is.
screw up the algebra after that, I don't care.
but can we get like bonus points, like if we do it correctly after that?
I'll make you a smiley face.
Okay, alright.
That's enough. Solid.
I mean, if it's something that you need to multiply out,
Yeah.
or if there's a need to multiply it out to make it easier to plug in a number, by all means. The only thing you might do here is you might turn this back like this.
Yeah.
Because when you go to the math lab, and like if you need help to solve, if you do.
Oh, yes, it shows you
It shows you
it.
all this stuff and it's so
showing you
confusing.
do it all. Yeah.
Well, I'll tell you what happened last semester. Last semester, I actually turned that off. I turned off, help me solve this and show me an example, because I knew that it was confusing 2/3 of the students. So I turned it off, and 3 people complained.
Uh-oh.
Those were the 3 people that never came to class.
Oh.
And they wanted to learn to do it off My Math Lab, which means they were totally confused. And so, if you want me to, I'll be happy to turn that off. But you don't have to do that.
It helps you to get started, but I mean.
Yeah, it helps you to get started, but then it gets, the further in the algebra they go, you're trying to decide when to quit.
Yeah.
Yeah. But for this right here, you can just put it in the.
Either one of those 2 answers right there is fine. Either one of those 2 is absolutely fine. Okay? This is not Mr. Thacker's calculus class. This is my calculus class. We're interested in answering questions about business. We're not going to be engineers. Okay, now this is a quotient. This is a quotient, meaning it's a fraction. There's a little bit of difference with a quotient rule and a product rule, but it still starts out looking at the 2 pieces, the numerator and the denominator. The numerator is this binomial. The numerator has a derivative. The derivative of 2x minus 1 is 2. The denominator is a binomial, and it also has a derivative. Its derivative is 4. Okay? Now what it's going to do
What
is
does that N stand for, man? I'm sorry.
N is numerator and D is
Okay.
denominator. Okay?
I'm calling them U and V.
Yeah, that's fine. That's what the book calls it.
So U on top, V on.
U on top, V on the bottom. The book calls the product rule U times V. But I just find this a little bit simpler when people can associate this with being the number on top and this is the number on the bottom, or, there's nothing sacred about the symbol. So the process here, now you have to be very careful on quotient rule, because quotient rule order makes a difference. Because quotient rule is not based on addition. Quotient rule is a subtraction. Okay? And what I always tell students is when you're doing a quotient rule problem, you start on the bottom. You go bottom up. So the first thing you do for a quotient rule problem is you keep the denominator you got in the denominator and you square it. Then you move to the numerator. And you still start with the denominator. But then just like product rule was, it gets the derivative of the numerator. And then your numerator gets the derivative of your denominator. And there again, at that point, your calculus is done. If you've done that correctly, then you've done all you have to do. Okay?
Can you enter that in the?
You can enter it into My Math Lab as long as you use enough parentheses. Now, I will admit to you, because of the parentheses and the extra things like that, sometimes it's hard to enter that in and get it exactly the way you want it. If it's not too much trouble to multiply the numerator out, you might want to. This one's not too much trouble. It don't have all these roots and things in it.
Yeah, that's when it gets bad, when you got 1/2 the square root of the
Yeah.
x and all that.
And get all that stuff stacked up, and it's harder to type that in than it is to type a whole bunch of parentheses in. So in this case, since this is just 2 times that, 2 times 4 is 8x plus 6. Be careful that if you are going to simplify that you remember this is a subtraction. So 4 times 2 is going to be minus 8x, and 4 times -1 is -4, but minus -4 is plus 4. And then 8x minus 8x disappears, and 6 plus 4 is 10 over 4x plus 3 squared.
So usually you square the denominator, is that just something you remember?
That's part of the rule.
Okay.
That's what the rule says to do. I could demonstrate to you, like I did with the product rule, that the answers come out to be the same if I had actually worked all that out another way. But this that's the way the rule works.
Okay.
Okay? You always begin with the denominator, put it in the denominator and square it. Then take that same denominator, put it in the numerator, and start swapping derivatives. And remember that it's subtraction, not addition.
I just want to make sure that wasn't something specific to this problem.
No, it's not specific to this problem. That's just the way you do it.
So why is a 4 a positive 4 when you find the 4 times -1?
Okay, because you're subtracting this whole quantity. Okay? So 4 times 2 is 8x, and 4 times -1 is -4, but you're subtracting that. So that changes the sign on the 4. So what's your signs? If you're going to simplify, you be really careful with those signs, because it will tell you it's wrong, because it is. Okay? So you think you can understand the product and quotient rule, okay?
Pretty easy.
Okay. This is a caution, it's in the notes. I just want to be sure you understand. The derivative of a product is not the product of the 2 derivatives. You don't take derivative 1 and derivative 2 and multiply them back out. It's not the way it works. You take the 2 derivatives and you swap them. And then you add what you have left. Okay? And if you're talking about a quotient, it's not the quotient of the derivative of the numerator and denominator. You don't take the numerator derivative and denominator derivative and say, okay, put a line between them and I'm done. There's more to it than that. It is a multi-step process. But just be careful that you understand that you have to do all the steps. And this is another big caution when you start trying to simplify things. I'm just trying to warn you of things that will get you in trouble if you do simplify. You cannot cancel that and take away one of those. You cannot do that. That is illegal in math, because this is actually equivalent to the expression written this way. That denominator actually belongs to both of those. So you can't just cancel out into one of the terms. That doesn't work. That's a very, very common mistake, so don't do that. If you're gonna do any canceling, you remember you want to multiply and combine like terms before you look for common factors. Now this is our last just pure example here, and this is a product rule combined with a quotient rule. So this is going to be a two-step process. The first step of the process is we're going to deal strictly with the numerator. We're going to totally ignore the fact that there's a denominator down there right now, because we need the derivative of the numerator to be able to do anything with the quotient. So the first thing we do is we're going to have to figure out what the derivative of the numerator is. So since the numerator is two factors, we're going to swap their derivatives with each other. And we're going to add it together. And then, only because we've got to use it again in another step, we're going to try to simplify it if we can. So we're only doing this because we're going to have to reuse it, and you don't want to have to multiply 7x minus 9 times all of that, because that's going to take too many sets of parentheses. So we are going to try to multiply it out and see if we can't shrink that down a little bit. 3 times 5 is 15. Minus 4 times 5 is minus 20. X. Plus, negative 4 times 5 is negative 20. X. And 1 times negative 4 is negative 4. And I notice here that my 20s combine to give me negative 40. Notice they did not cancel out. They add together. So watch your signs. And then 15 minus 4 is plus 11. There's the derivative of your numerator. Okay? That's the derivative of your numerator. And this is your numerator right here. Now we go ahead and do the quotient rule. So the derivative starts out with the denominator, and it puts it back in the denominator and squares it. Multiplies it times itself. Then it takes the denominator to lead off in the numerator. You have to lead off with the denominator. And then you want to multiply that by the derivative of that numerator. And then you're going to subtract. And you're going to take that numerator and you're going to multiply it times the derivative of the denominator, which is just 7. And you can multiply that out, or you can leave it alone. Since it is a lot of parentheses, if you want to multiply it out, that's fine. Now, if you do multiply it out, 7 times negative 40 is negative 2. 80 x squared. Negative times negative 40 is plus 360x. 7x times 11 is 77x. Negative 9 times the positive 11 is negative 99. I think it would be easier to change this into 35x plus 7 and then multiply that by 3 minus 4x. So that's going to come out to be minus, see, 3 times 35 is 105x. Minus 4 times 35 is 140. X squared. 3 times 7 is 21. Negative 4 times 7 is negative 28x. And I'm going to subtract all of these from those. So here I've got minus 105x. And I'm going to put that 77x down there with it. And at minus 28, subtract negative 28 would be positive 28x. That takes care of that. I've got a 21 here that I'm going to subtract from the 99. And minus negative 140x squared is going to be plus 140x squared. So it is going to look a whole lot better if you do try to clean it up. I'll be the first to admit that. This is, I don't trust my math ability this time of the day. That's why I have a calculator. Negative 280 plus 140, I left out my 0.
Got 21 under the 99 there, should we add that?
No, because you're subtracting a positive. Okay?
Yeah.
Change all your signs. So that's going to be negative 140x squared. And then I've got 360, oops, 360 minus 105 plus 77 plus 28. So that's going to be 360x. And then minus 99 minus 21 is going to be minus 120. And that's all over 7x minus 9 squared. Now I'm sure some My Math Lab programmer factored out the greatest common factor and tried to factor that binomial, but you know, I don't think it's worth it. It looks fine to me. If they wanted to do that, they could do that. That's as far as I'm willing to go. Actually, I think I might have been happy with the orange box. Because if I was trying to plug in x equals 2, how hard would it be to plug in x equals 2 in that top box? Probably almost do it in your head, right? So there's your derivative, and this is as complicated as it's going to get, where you have to do 2 rules within one problem. Okay? So that's actually the last of the just straight examples that I have. The only other thing I've got in this section is we're going to talk about something called average cost. Average cost is the cost per item. Just like your average test grade is the total of all your test grades divided by how many test grades. Your cost of 10 items, your cost per item is the total cost for the 10 items divided by the 10. Okay? So average cost is simply the cost function divided by x. You just need to remember that. That's a definition. Average cost is cost divided by X.
What is the thing here says the rate of change of average cost called the,
Okay, when you're talking about the rate of change of average cost, that's the marginal average cost. And here again, marginal is your clue that you're talking about a derivative.
what page is that?
It should be the next one, the very next page after the example we just did.
I got this one called blanks on it.
Okay, now the rate of change of cost, I want you to think about this. You started up a business and you have a cost function. And most of the cost functions we've ever talked about have been linear cost functions. Okay? Linear cost functions were the fixed cost, you know, the cost of renting the building, buying the machine, setting up shop. And then there is a certain cost associated with what you make for each item. And you know that if you make more items, that your marginal cost, your not fixed cost, your changing cost, is actually going to change over time. Because as you make more items, you have to buy more stuff. And you have to hire more people, and you have to work more hours. So as the number of items you make increases, then that part of your cost isn't fixed. It actually is going to increase too. Now, all cost functions are not linear. If they were, then marginal cost is always going to be the number in front of X. But not all cost functions are linear. So they don't all have a constant rate of change. And in fact, in business, if you think about it, does it make sense that when you first start making something, your cost per item is going to be a lot higher for your first 100 items than it is for your last 1,000 items? Because what happens is you make more and more of something. Talking strictly about cost, if you make more and more of them, and you buy the materials to make more and more of them,
Pay your labor and everything. So
you do still have to pay your labor, so it still goes up. But if I go to Sam's and I buy a case of water, and I buy their case of water, which is probably like 100 bottles, how much per bottle is that going to be compared to if I go to Walmart and buy just 12? Okay, if you buy more, what usually happens to what you're paying for it? Your per item cost becomes less. Okay, because you're buying in bulk. Think of it that way, you're buying in bulk. That's why all cost functions aren't linear. Okay? The cost of your early items that you produce is going to be a lot higher than your cost for your later items that you produce. Which means the rate of change of cost is not going to be the same throughout your entire production. So here's a much more realistic cost function. Okay? That's a much more realistic cost function. Now, I'm not going to teach you how to find cost functions. That gets into another whole course called mathematical modeling. But they used information to come up with this equation to tell you how your cost works for this particular item, which happens to be small motors. The things that you need to pay attention to, once again, X is measured in hundreds. Okay? Pay attention to that. X is measured in hundreds. If this is 10X, that means that's 1000 when you actually use it. That's 1000. And this is 200 hundred, which is 20,000. Okay? So remember, the value of X has units. And this is the cost in dollars. So when we start answering questions, we have to pay attention to those words. The first thing that we need to talk about is, what about this stuff about average cost? It says find the average cost per 100 motors. Okay? that means that you're going to take your cost function, C of X, and you're going to divide it by the number of motors that you're going to make. So your average cost per motor is C bar of X. That's the way you say that, C bar of X, or the average cost of X motors. And that's a cost per 100 motors. Now, that doesn't look too bad until you start thinking about, wait, I got to divide that by X. Okay? So this is just a reminder of some algebra that you may have forgotten. If you have 3x squared plus 120 divided by 2x plus 1, and you're going to divide that by x, it is far simpler to do it this way. You've seen me do this before when we did limits. Dividing by x is the same as multiplying by 1 over x. And that leaves you with something that looks a lot easier to find the derivative of than this does. This looks terrible. But if I simplify this out, finding its derivative won't be as bad. So the numerator, it's not going to change because I'm multiplying it by 1. My denominator is going to be multiplied by x. So x times 2x, 2x squared, and x times 1 is x. That's your average cost function. So, and again, I'm going to make sure that you interpret right. The average cost of producing X hundred motors is 3x squared plus 120 over 2x cubed plus x dollars. And since it is an average cost, that's dollars per motor. Actually, well, let me back up on that. Per X hundred motors, since it is measured in hundreds. Now, I wouldn't necessarily tell you have to write that down at that point, but I want you to be sure you understand that that is what it is, because it's going to be important to understand that when we talk about the derivative of that. Okay? Because that average cost is going to change. Sometimes it's going to increase. Sometimes it's going to flatten out. Sometimes it's going to decrease. It will change over time, depending on how many motors that you're making. You understand how to find the average cost?
Ms. Flynn, there at the bottom, is that 3x squared plus 120?
Yeah, same thing as this. It's that same thing. I'm just putting it into a sentence so that you realize that this is actually dollars per X hundred motors.
Yeah, I just started confused.
Okay. Now, part B asks for something more. It says find the marginal average cost. Find the rate at which the average cost is changing. be careful about your verb there, because when you talk about the marginal cost at a specific value of X, it is that the cost is changing by this much when you produce that many. So the marginal average cost, well, first of all, we need the marginal cost. So I have to go back and get the marginal cost. Marginal cost was 3x squared plus 120 over 2x squared plus x. And I need the derivative of that because that's what marginal says that I want. Marginal says find the derivative. So in other words, I want to find C average prime. What rule do I need to take that derivative? There's your quotient rule. We have a numerator, and its derivative is 6x. We have a denominator, and its derivative is 4x plus 1. Okay? So remember, I always start off with the denominator. And then I use the denominator again to build my numerator. And I'm going to multiply it by the derivative of the numerator. And then I'm going to subtract the original numerator times the derivative of the denominator. So there's your marginal average cost formula. Okay? Can you simplify it? Yes. Do we want to? Not if we can get out of it. Okay? So we're going to use that and see what part C says.
What is that, C bar or
C bar prime.
C bar prime?
Now, what you're going to see in the next chapter, in chapter 13, is that average cost is generally minimized when the marginal cost is 0. What would it take to find the minimal cost? The minimum average cost. Because isn't that what you want your cost to be? You want your cost to be as small as you possibly can get it. Okay? So what that means is we've got to take this and we've got to set it equal to 0. Now when I do that, before I go too far down that road, I want to ask you to think about something simpler with me. What's the only way that that expression is ever going to be equal to 0? What has to happen? Yeah, whatever it is in the numerator is going to have to turn out to be 0, right? So does it really matter what the denominator is? So even if I wrote the denominator and I told you the denominator was 7x cubed minus the square root of x to the 5th power and a whole bunch of more stuff, does that change the fact that that's only going to be 0? if 3x plus 1 is equal to 0? The numerator has to be a 0, right? Doesn't matter what the denominator is. As long as the denominator's defined for whatever we find the numerator to be equal to 0 for, we're okay. We don't want 0 over 0. That's the only thing we got to worry about. So what we're going to do to solve the problem that we're looking at is we're not going to pay any attention to this to start with. And as a matter of fact, that's probably not ever going to be 0 anyway, because you're squaring it, which means that whatever's in here is negative numbers. It's going to come out to be positive, and if you put in zeros, well, okay, then maybe 0, but do you ever want to make 0 something? So we're not really worried about a 0 denominator here. That's not logical. What we want is to find out where is 2x squared plus x times 6x minus, and I'm just going to turn these around because I started writing them the other way around. 4x plus 1 times 3x squared plus 120. Now remember, that's a subtraction problem. And that's going to be equal to 0. We only care about making that be equal to 0. Because that tells us that if our rate of change is 0, our average cost is no longer increasing and it's not yet decreasing. Okay? Or it's decreasing and hasn't started going back up yet, which is the more likely situation. That's really what we want. And this is a parabola that would open up anyway, so the cost is going to, average cost is going to decrease, bottom out, and then it's going to increase again. Now that still doesn't look like a whole lot of fun, but it's not as bad as it looks like it is. 6x times 2x squared is 12x cubed. 6x times x is 6x squared. 4x times 3x squared is 12x cubed. 1 times 3x squared is 3x squared. 4x times 120 is 480x. And 1 times 120 is 120. And remember, this is all being subtracted. So that's going to be minus 12x cubed minus 3x squared minus 480x minus 120. And when I combine all that and put like terms together, that disappears. Thank goodness, because I sure as heck didn't want to have to factor a cubic. 6x squared minus 3x squared is positive 3x squared minus 480x minus 120 is equal to 0. All of these can be divided by 3.
Wait. Did you mean to put that in a fraction? Or is that just like a line?
I'm dividing all of these by 3. I'm going to take out the greatest common factor of 3.
Oh, okay.
Okay, to make the factoring or the quadratic formula easier. Okay? So when I realized that all of those have a greatest common factor of 3, then I have something that's a lot easier to solve. X squared minus 160x minus 40 is equal to 0. Now, I'm not a huge fan of factoring. I kind of like quadratic formula. So the quadratic formula says that A is equal to 1, B is equal to negative 160, and C is equal to negative 40. And the quadratic formula says that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So it's all basically just some arithmetic now. The hardest part of that formula is going to be what's under the square root. So what's under the square root is b squared, which is negative 160, minus 4 times 1 times negative 40. So I need to take that square root. So let me do the negative 160 squared minus 4 times 1 times negative 40. That's 25,760, and hope we're going to cross our fingers that actually would square root. So we're going to take the square root of that. Okay, we'll call it 160.5. Okay. So then the opposite of b is 160 minus or plus, and 2 times 1 is 2. So if I say 60 minus 160.5, do I get a positive answer? No, I get negative 0.5, right? Okay, negative 0.5 over 2, regardless of what it is, it's still negative. Can I make negative numbers of anything?
No.
No, so I don't care. I don't care about that number. But I do care about this one. Do care about that. 160 plus 160.5 divided by 2 is 320 divided by 2. Which is 160.25. But remember, at the very beginning I said, what does x count? How is x measured? As hundreds. As hundreds. So 160.25 as hundreds.
So what are we calling that number, 160 for
The square root, we said it was really, really close to 160.5.
Yeah,
Close enough.
okay, so
Okay.
we got 160 plus or minus.
Yeah. And if you do minus, you get a negative answer, which you can't make negative anythings. So here's what our answer actually is. Here's our final answer. Average cost is minimized if 16,025 motors are made. That's the answer to the question. The arithmetic doesn't always come out nice.
Can you you zoom out so I can see the whole problem? Because I got
Yes.
lost a little earlier, but I think I might be able to find my way back.
Now, let me slide it down so you can see both, because actually Judy used part of the next page to write the final answer. So can you see it from there?
Yeah, I guess I'm just confused as to how you got it. Like, because at the beginning when I did it, I just went ahead and distributed like, out here, I'll show you what it is. So like, whenever I wrote it out, I just multiplied the negative, I went ahead and distributed that, and then I multiplied these together. So I'm just so whenever you did the greatest common multiple factor, I got really confused. So what happened?
This is not x squared, this is x cubed.
Okay. But
Almost in the
I
same
have
thing.
that up there, sorry.
Yeah, but see, then you got 12x cubed minus 12x cubed, they cancel. Okay? Double check your math, but those are all right. Okay. Did do that, and then. Yes. Everything happened there. Okay? Okay, is everybody good with that one? I have a challenge for you. There's your challenge. I'll give a free 100% quiz grade to somebody that can tell me what it is before I know what the answer is. I didn't simplify it, and I didn't do it by anything you know how to do yet. Why are y'all not done? How are you trying to do it? You're trying to do this, aren't you?
Actually, I'm just trying to find the class, but I'm
It's 5x to the 4 plus 6x squared. Is that right?
You mean, you want the final answer?
No. Yeah, I'm still solving it.
Okay.
Oh my God.
Well, when you get done doing this, I'm going to go ahead and tell you. Wait, no, I can't do that.
Sometimes when I'm going around for a walk and I realize I'm actually not for a walk. Sometimes it's confusing. And then she actually does problem with that. Hey, Target's having a sale on jewelry. Nice. I should just work at Target.
Oh, I got got it. 6x to the fifth plus 30x to the fourth plus 1.
That is the derivative. But I had to use algebra to show you that mine was the same as yours.
Obviously, me too.
Okay? That's a preview.
I will.
You're gonna learn how to do what I did next class period.
But I
Okay?
don't know what.
This is called the chain rule.
Problem we just did.
How many people had calculus in high school? You know what the chain rule is? Yeah. Okay?
Wait, does that mean you got it then? Does that mean you got it? Nobody get that free 100 point?
I got it.
Wait, but
I beat you.
I was calling it out.
But I beat you.
No, yeah, sorry.
Okay, see what
I'm gonna go cry now.
I will give you this. You were actually able to simplify that in your head using the process. Yeah.
Okay.
You did good.
Smiley
You did
face.
really good.
Yeah, let me stay here.
Maybe I'll give you bonus points on next time.
Okay.
Because that's not easy to do in
Yeah.
math. Yeah. See you later. Yeah, just be sure you do that because that's a very useful thing to know how to do.
How good is this one?